Hello, my name is Fricke Müfke, and I'm following the Blockstack project for some years now, and I contributed to the project in Android and created some Blockstack apps. And I'm happy to introduce you to Misha Benoyel. He is the founder of Open Garden, who created the FireChat app, and he developed communication networks, and now he's working on Nodle. And he's taking the concept of the decentralized communication to the next level when he's talking about contact tracing apps. So, Misha, it's your floor.
Hi, Fricke. Thank you for your intro. Good to meet you all, and very excited to be presenting today for this session. I am going to put my screen. Can everyone see my screen correctly? Yeah. So I am basically going to talk to you today about why contact tracing apps may pave the way of a new generation of more private social graph and networks. And I think it's a very interesting topic, and I'm going to try to convey and share our discovery with the team on this topic, and to give you ideas on things that can be developed leveraging basically the technology we developed, which is a protocol for contact tracing or exposure notification that does something which is very, very important, which is actually to protect people's privacy. And along this presentation, I'm going to tell you a little bit about my journey, how I came to work with using the Bluetooth interface on smartphones, explain and show you some of the great things we did leveraging Bluetooth, and how more recently with this crisis of COVID-19, we went to actually leverage the Bluetooth interface to solve the problem of COVID-19 by helping trace better the virus, and how we can do that while protecting people's privacy, which is really why we put so much effort into this protocol I'm going to present later called the Whisper Tracing protocol. So here you have my name. I use my second name as the Twitter handle. If you want to tweet me or contact me, it's Antenor. So when 10 years ago, when I started on this journey of building networks and communication networks, leveraging Bluetooth, we started, my team and I, and at that time I founded a company called Open Garden. We started by building a solution to share bandwidth. So we launched an app that was creating a mesh network. To be more precise, it was enabling smartphones to communicate with one another and interconnect directly using Bluetooth and some techniques of and versions of Wi-Fi, like Wi-Fi Direct, and that way enabling you to access the internet better by being able to share bandwidth with other people, share bandwidth with your devices, but also benefit from other people's bandwidth when you were in this mesh network. What was pretty amazing is in 2011, when we started, when you wanted to have a hotspot on your smartphone, it was costing you like $50 a month to activate it. And we got a good success and millions of installs, because when you were using our application to share bandwidth, it was completely free. As we moved along the development of this project, we realized that there was more actually behind just connecting to the internet with mesh networks and mobile mesh networks. But we realized it would be a way, leveraging Bluetooth, also to move information between smartphones that are in proximity. And at the beginning of 2014, we leveraged that technology to ship a mobile application that many of you know called FireChat. And we wanted first to show that we could enable people during the Festival of Burning Man to stay connected. So we launched the FireChat mobile application that was enabling you to communicate and send messages with one another if you all had the app in your camp, and be able to stay communicating. It was pretty amazing. It was, so like I mentioned, using a lot of the Bluetooth interface. One of the major things we overcome at that time is we found a way to actually avoid pairing. So you didn't have to actually accept connections that were coming in and out. If the phone had the FireChat app, it could automatically connect to people around, discover them, and send messages in big chat rooms. And we got more than 10 million installs of FireChat. So after this event of Burning Man, another major thing that happened was actually the pro-democracy protest in Hong Kong. And it started in September 2014, called the Umbrella Movement, continued through the beginning of October 2014. I was pitching the technology in India and decided to stop for the weekend in Hong Kong on the layover on my way back to San Francisco. And after 24 hours in Hong Kong, I realized that 100,000 people had installed the app, so I decided to stay. And they did that because they were actually preparing and organizing their movements. So it was a pretty unique time. Crazy personal experience. I decided to stay. I spent 10 days in the city of Hong Kong. I didn't sleep during all that time because I had to communicate with my team in San Francisco and make sure we could maintain the service, which was having a lot of people subscribing to, but also a lot of attacks, as you can imagine. So the app was pretty amazing. We had 500,000 installs over the 10 days when I was staying in Hong Kong, which is a lot. And then, so that's me in Hong Kong, actually, among the movement, because I wanted to understand how people were using the app. And we had some funny moments, like we made it to a John Oliver show with FireChat. That was a lot of fun. And then the app kept on being used for music festivals and also to help during disaster recovery situations, like the flood in Chennai in India. And so after that adventure with FireChat, I realized that, we could leverage what I call the smartphone infrastructure, and more specifically the radios in smartphones and Bluetooth to do much more things. And so one of the projects basically I'm working on now is called Nodle. So Nodle is an amazing network. We leverage smartphones to connect sensors and devices, and that way build a network which is completely software and can spread out very quickly. And the way we build this network is by partnering with app developers who install our library to help us expand the network. So they use that library into their app, and they get paid through a cryptocurrency called Nodle Cash for moving data. So by doing that, we build what we call the citizen network. You can also use that mobile application called Nodle Cash, which is a wallet, to actually participate in the network and also be compensated for participating. And so more recently, as we were working, and we are still working on the Nodle project, when we started the confinement in San Francisco, and that was back in mid-March of 2020 of this year, we saw an initiative for contact tracing by the Singaporean government. And we saw they were using Bluetooth to actually enable automated contact tracing, now called exposure notification. And we saw that because of all we knew in cryptography and with Bluetooth, we could bring to the market a solution. And we saw also it was very important that would protect people's privacy. And it's very important because if you look at a recent Harvard study, if you wanted to do a good job at actually fighting COVID-19 today, you will need to perform almost, for the US alone, like 100 million tests a day. It's technically impossible, but if you use solutions like automated contact tracing and contact tracing, you can take that number down to 5 to 10 million. So it's a very important thing. So that's why we really realized we could make a big contribution and help by bringing to the market a contact tracing protocol that would protect people's privacy. So we did that by bringing a solution called the Whisper Tracing Protocol. We worked around the clock for between mid-March and beginning of April to bring the solution to the market. And I'm going to just spend a bit of time explaining to you what is contact tracing or exposure notification, so you can understand better the role and how it works. This is a graph from Oxford, actually, that explains that how contamination happens. And so the role of contact tracing is to alert you faster in the event you had spent some time with someone who was infected. So by using a mobile application, what happens, everyone installs the app, you can tell it to your family, to your community to have the app. And if one of the person in that community basically is tested positive, automatically other people who have the app are going and who spend time with that person are going to be notified, and basically that way they can be tested faster. And in the event they were also contaminated, then you can avoid the propagation of the virus. So it's a very important element to fight COVID-19. Like I mentioned, this technology is using Bluetooth, and we implemented it through a protocol that has been peer-reviewed by students at MIT, Stanford, USC, and Oxford. When we developed it, it was its first version back in early April. We published it, and now we are at the third version of this protocol. So we improved it a lot. We shipped an app on Android called the Coalition app that basically does contact tracing. We also have a version on iOS that implements the third version of the protocol, but the iOS version is not live. Is not live yet. We were really doing that ahead, I think, of a lot of people. In Europe, there were some very good initiatives also and pretty advanced. What was interesting is to see that we all came up with the same conclusions for how to make a solution that would enable privacy. And a bit later, I think as we were shipping the app, Apple and Google announced they were working on their exposure notification protocol, which is inspired directly from this work that we were all doing to protect people's privacy. And I think it can be much improved. And in the third version we have now, we also add a lot of features while protecting people's privacy. Why using Bluetooth for doing the job of basically contact tracing or exposure notification? Because Bluetooth is present on every smartphone, and it's great for privacy if it's used properly. Other solutions for contact tracing would be using cellular, but I mean, cellular is not very accurate when it comes to estimating distance between people. It's also data that the carrier has. It's very centralized. There's no opt-in. I mean, anytime a telco basically can figure out where you're located if they use their network of cell towers. GPS is another solution for contact tracing, but the same thing. GPS is very intrusive, especially when it comes to privacy. It is more accurate in terms of distance than just using cell towers, but still. You can have a lot of situations where it doesn't work, like if you're underground in the subway. So a lot of situations where actually you may have many risks of contaminations. So Bluetooth is very appropriate, works very well. And with a protocol like the Whisper Tracing Protocol, we were able to actually make these interactions stay completely private. And when it comes to estimating range and distance between people with Bluetooth, in the current implementation of Bluetooth on smartphone, it is not as optimal as it could be with the latest evolution of the Bluetooth that we use for specific wearable devices we built. So that's, for example, a device we built with my team called the Nodle M1 that can measure distance very accurately down to 10 centimeters accuracy using Bluetooth. So on the smartphone, you can use the signal strengths. There are a few papers that have been published and explain very well how that can be achieved. And using signal strength, you can estimate if someone is within a short range, let's say less than 6 feet, or it's above 6 feet. And that's enough actually to do a good job for contact tracing applications. So the interactions between the smartphones stay private. And in the third evolution of our protocol, the way it works is device recognize they are carrying the same service. they exchange random identities and generate what we call an interaction token. And if you are basically tested positive, and if the app knows that you are tested positive because you have been receiving a confirmation test or you have been declaring yourself as tested positive, then in that case, all your interaction tokens are moved to the cloud. They are completely anonymous, and they're going to be shared, and people who you have been spending time with basically will be able to retrieve these interaction tokens and check on their phone and if they were spending time with you. In the event that they were spending time with you, then they're going to receive a notification through the app telling them that they have to be tested and they should stay at home because they had been spending time with someone who was declared positive. So this graph explains a little bit of how it works and the process. And I mean, I can answer some of your questions later on the process and how it works. As we were working on that, I mean, we had like a lot of thoughts and new ideas coming up, which are, I think, pretty exciting. And one of the reasons I wanted to convey and share this with you today and do this presentation is because I think that what we have discovered and what we have developed by using this way of recording interactions among people can be used to actually a lot of use cases to create more private social graph and networks. And I think that's very important. And it can be used in the context of contact tracing, like I was explaining. And I have two examples here I can share with you. So, for example, in this example one, imagine you are meeting a friend, and so this friend is A, you can see here on the graph. So, and let's say you are C. So basically, you meet A, and in the normal context of contact tracing, if B basically reports that it was tested positive, or if the app basically received a test confirmation that it was tested positive, automatically the system is going to notify A and say, oh, you have been spending time with someone who has tested positive. We recommend you stay at home and that you get tested. Now, I mean, that's the normal context. And in this context, basically, C might also be at risk. But the only way for C to be notified is only if A, in that case, was tested positive, and in that way, C could be notified. What's interesting is the system actually, through the private social graph, is aware of all these interactions. So where we think it could be improved is, for example, when A meets C, if B, that basically was the person who was infected, who transmitted the virus to A, if that's basically if A basically is meeting B for not the first time, but or the first time, but basically is meeting B, which is a person with who normally A haven't spent time with, then the system knows. So when A and C meet, for example, one interesting notification that could happen would be, oh, you should be careful because one of you has been meeting with someone new, and basically you should make sure you keep your social distance. And I think this kind of notification could help actually improve the behavior of people, and that way trace better the virus. Another interesting use case in the case of contact tracing is with ride sharing. So for Lyft and Uber drivers, for example. So if a driver who is A, and that's the example 2, takes a passenger who is B, then if B gets infected, then the driver A is going to be notified to be tested. But maybe the driver, after carrying B, basically just after B, carried C and carried also person D. So what we think is, in that case, the system for drivers alerts basically should be fine-tuned and actually realized for specifically for and work for drivers. And not only it should alert A in that case, but it should alert C and D who came in the cab just after B. So that's the kind of thing that we think can be improved using this private social graph. And another application which I like a lot, and I think some people tried to do these things in the past just using geolocation. It's, for example, how you can increase serendipity. So serendipity is basically an event that benefits you in the future. But there are many of these events where and situations where we meet people and we don't know all these people. So in the case, for example, of dating, you could easily have some information popping up on an app telling you that, oh, you know, you have been crossing paths with a person you don't know that shares the same interests as you more than 5 times this week. And that way you can create a whole new, I would say, generation of dating apps and scenarios where you can highlight these connections and then based on shared interest also probably generate very, very good matches among people. Another good example is during conferences, business events, where if you had this kind of private social graph embedded within an app for the event, for example, you could automatically have your contacts shared or receive the contact information after the event of the people that you have been spending more than 5 minutes with or 10 minutes with in proximity. And that way you don't have to do this complex work of exchanging business cards anymore or contacts anymore. You can basically just pick the people you want to stay in touch with. So that's, I think, also is a very interesting thing. So I wanted to share that with you. I would love to hear your questions, your comments, and your ideas. Again, if you want to contact me, that's my Twitter handle and my email with the Coalition Network, which is the nonprofit that is publishing the Coalition the Coalition app. Thank you for listening, and looking forward to your questions. Okay. Okay. Sorry. So yeah, I was saying regarding Apple. So when we published, we were really in the urgency. We actually published through the company's account, which was the Nodle account, to try to go fast. And Apple rejected the app because apparently there was basically a new guideline where you can only publish if you are a health related organization or a government organization. So I mean, it's pretty bad. We thought I mean, if we had the chance to publish like beginning of April, I think we would have made much more faster progress actually on the app. We have very good intentions. We never had any intention of actually scamming or trying to acquire a lot of information through this app. We did that to help. So we pushed this app into a nonprofit called the Coalition Network Foundation now. We created a board with epidemiologists, MDs, a lot of people in health, and we are going to resubmit the app to the App Store. And we hope that's going to work. We may do that also with a university, medical school, in partnership with them, or in partnership with states or cities that also want to use the mobile application. Just for your info, we helped actually the French government on the Bluetooth stack for their own apps. We also are helping the Senegalese government, who is going to use the whisper tracing protocol in its latest implementation. So some of the others, so that's to answer your first question on Apple and Google. Jenny, so on your question on distance, so I think I sent you through Twitter actually a few papers. I mean, you will see that we can do on smartphones a good binary distinction between basically contacts that are established within less than 6 feet or contacts that are established further than that. It's hard to get good precision when it's above that, but with the signal strength, you can have actually a pretty good idea of proximity. And these are the interactions that counts because they're the one that you record in the system to be able to alert people in case basically you have spent more than 15 minutes, for example, within the 6 feet with people. So there are other questions. Okay, I see the tab. So okay, so DP3T. So how Whisper differ from DP3T? They were inspired from the same, I think, spirit. And DP3T in its first implementation is very close to our first implementation and what Apple, Google did. In our latest version 3, we integrated actually many of the privacy recommendations from a working group at from an institute in France of scientists called INRIA. I think DP3T has one of their implementation actually thinking in the same way. So it's very close to DP3T. I think we've done a very good job at implementing it into the apps. So we maybe made this thing concrete, like it's not only a paper, but it's very close, yeah. So I have other questions on with so many contact tracing and risk scoring protocols and apps, thought on or how, say, the US converges on one or reaches interoperability. So to have this contact tracing app works together, there needs to be interoperability. And for that, there will need to be basically exchange of infected random identities or infected token interactions at the cloud level. We have worked in our latest implementation of the protocol on a way to do a decentralized solution to actually have different contact tracing apps sharing these interactions to enable interoperability. I think you should read if you are interested in that, the protocol, the Whisper Tracing version 3, and you will see that basically, there's a solution there that can be done. So I have another question, 3 questions that kind of relate to each other regarding how we can trust Nodle. Okay, how can one trust that the privacy-preserving service offered by Nodle are actually protecting users' privacy? Is there an ability for developers to review the source code of the application? Are there any third-party audits covering the service that handle personal identifiable information? So yes, I mean, we can show the code of the SDK to developers. We did it for a few big partners. I mean, you can also do your own diligence and dig into the Nodle SDK to figure out the data. But we did, I think, a pretty good job at randomizing all information there. And so I think, I mean, the team has done a pretty good work. at protecting people's privacy. There's no information asked about the users and no information captured about the users. So far it works pretty well. We have, just for your info, I think presence, on millions of phones, and every day it's more than 5 million smartphones that basically move data through the network actively. Let me see other questions. Well, I think that these are the 3 questions I just saw. Yes, that's the paper. Yeah, Darren. So someone asked about the whisper tracing protocol and if it was so Desire, for example. So Robert is on a centralized server, and Desire is actually the new suggestions that we implemented in our protocol for the version 3. What's interesting in this implementation of Desire that we actually have in the whisper tracing version 3, it can be run in a fully decentralized way, or it can be run in a semi-decentralized way to provide local health authorities to have information while protecting people's privacy, which you cannot do in the first version actually that we had, or the first version of DP3T or the Google Apple version. So for example, you can, while protecting people's privacy with a semi-decentralized model, you can still have a server know how many people get alerted, how many people actually were infected, which is a very important information when you're trying to trace the virus. So that's, yeah. I hope, Harry, that answered your question. Thank you, Shannon. Thank you, everyone. I think that's it. And I hope I have answered your questions.